Good afternoon and welcome to your science review with Mr. Blades. Today we're going to be discussing speed and velocity. Let's get started. Our study of physics begins with the concepts of mechanics. Specifically, we're going to talk about kinematics, which is how we describe motion. All right. And from then we're going to talk about the causes of motion or dynamics. So as you can see, kinematics is when we're discussing the motion, and dynamics is concerned with forces. Motion occurs when something changes position. Now, distance is how far something has moved from where it began. We measure this in meters, kilometers, miles, inches, millimeters, but more often than not, we discuss things in meters. Now, similar to distance is a concept known as displacement. While distance is how far an object has traveled, displacement is how far from the starting point an object actually moved. Displacement does not equal distance traveled. And this is primarily because displacement involves direction. If you walk backwards and then walk forwards, some of that displacement is erased. If we take a look at the following diagram, we can see that our astronaut moves from his starting position 30 kilometers to the right at an angle 20 kilometers down and 15 kilometers back to the left. However, he is only 15 kilometers from where he began, so his displacement is only 15 kilometers. Now, how fast something is moving is its speed. It's the distance an object travels in a certain period of time. Now, because speed deals with distance rather than displacement, speed is also not a vector because it doesn't include direction. So what is his rate of speed? Now, if our little astronaut takes 30 minutes to travel 30 kilometers, what is his rate of speed? Speed is distance divided by time, so 30 kilometers divided by 30 minutes, and we get 1 kilometer per minute, or 1 km divided by 1 minute. So we're going to talk a little bit about graphing speed. Now, if we take our distance divided by our time and graph it with distance on the y-axis and time along the x-axis, we might get a graph like this. If the line is straight, regardless of its slope, if the line is straight and not curved, it is a constant speed. If the slope is positive, it means it's a constant speed above zero in the positive direction. So let's discuss a little more about constant speed. Just like in the last slide, you can see that this straight line implies that there is a constant speed. For every 1 second, 10 meters gets covered. But let's talk about slope of the line. As you probably remember, slope is rise over run, or change in y over change in x. Another way to write this is y2 minus y1 over x2 minus x1. And again, this is just known as rise over run. And in this case, we end up with a velocity of 10 meters per second. So what's happening here? We can actually see now we have a speed versus time graph rather than a position versus time graph, and we have a flat line. Again, this means that the speed is not changing. And because this is a speed versus time graph, it means we have a constant speed. But velocity is speed with direction. Velocity is what is called a vector and therefore includes a direction. Velocity is something we need to completely describe motion. It allows us to talk about the speed of an object, but also its direction. So if we have our little astronaut, if we tell you that the moon man moves 40 kilometers, that doesn't tell you where he is because he can move 40 kilometers in any direction. In fact, he could just walk back and forth until he had walked 40 kilometers. We need to know the direction. When describing velocity, we have to state the direction. We can say something is to the east, west, whatever. And normally we describe this with either a positive or negative sign. Sometimes speed changes. Just like with position, we can have a velocity versus time graph that reflects a change in velocity. This changing speed is called acceleration. Just like a change in position over time is velocity. A change in velocity over time is acceleration. Acceleration can also be called changing speed, how fast the speed is changing, and it's measured in units of meters per second, or meters per second squared, or a change in velocity per second, or meter per second. Now, if the acceleration is 10 meters per second, per second squared, the object is increasing its speed by 10 meters per second every second. So how fast would it be going after 5 seconds? So if we take 10 meters per second squared, multiply it by 5 seconds, we end up with a 50 meters per second, just like it shows up here. Now, we talked earlier about a position versus time graph. If the line was straight, it means it was traveling at a constant velocity. But we can see here what we have is a curved line. That curved line means that the velocity is changing. And we can see that that's true because our object is accelerating or getting faster. But if we look at a velocity versus time graph, in that case, it's going to be a straight line because the velocity is changing at a constant rate. Acceleration, just like velocity and position, can be positive or negative. Negative acceleration usually means that the object is slowing down, but it just actually means that the object is accelerating in the negative direction. Now, if you have a positive velocity and a negative acceleration, then the object is slowing down. But if you have a negative velocity and a negative acceleration, then the object is speeding up. Some other cases of acceleration are things that are changing direction, things that are increasing or decreasing in speed, but we'll talk about those in more depth later. So which one is which? We have two position versus time graphs. Which one has a changing velocity? As from our discussions, you can tell now that it's the one on the right. The one on the left with a straight line is a constant velocity. So what's happening here? First things first, let's take a look at what kind of graph we have in front of us. We have a velocity versus time graph. That means that all of these lines in here indicate certain changes in velocity. We can see that at the very beginning, at our y-intercept, our initial velocity is 0. We have a velocity of 0 to start with. And from 0 to 1 second, we go from 0 meters per second to 40 meters per second, which means that over the first second, our acceleration is 40 meters per second. But then over the next 3 seconds, we go from 40 meters per second up to 100 meters per second over the next 3 seconds. So we go from 40 to 100, or a change of 60 meters per second in 3 seconds. And that would give us an acceleration of 20 meters per second. Now we have the longest section of the graph from 4 seconds down to 14 seconds. You can see that we have a negative slope to our velocity versus time graph, which means that we have a negative acceleration, or acceleration in the negative direction. What this means is that from 4 seconds to 9 seconds, since we have a positive velocity above the x-axis, we are accelerating in the negative direction. So you can see that our object is slowing down from 100 meters per second to 0 meters per second from 4 to 9 seconds. So we have 5 seconds and a negative change in our velocity from 100 to 0. So negative 100 divided by 5, our acceleration over that period is negative 20 meters per second. Now, as our graph crosses the x-axis, our object stops briefly as the velocity equals 0. But then after that, it turns around and heads in the negative direction, accelerating at that same acceleration of negative 20 meters per second. Instantaneous speed, that's what we're calculating when we calculate the slope of our graph. What is the average speed of a car that travels 350 kilometers in 5 hours? Is it 7, 70, 300, or 750 kilometers per hour? Again, we're going to have a total distance of 350 kilometers divided by a total time of 5 hours. And what we end up with is 70 kilometers per hour. So, real quick, which graph shows constant speed? Which graphs show acceleration? All of these are graphs. Let's take a look. A is a speed versus time graph, and you can see the speed is going up, so it can't show constant speed, but it is a straight line, so it would show acceleration. So graph A shows acceleration. Graph B is a distance versus time graph, even though it's marked wrong in there. It's distance versus time graph, and it's got a straight line as well, which shows a constant speed. And because it's a straight line, there's no acceleration there. Acceleration is the subject of graph C, acceleration versus time, and it is above zero, but it's flat as well. So the acceleration isn't changing, but it's above zero, so it does show acceleration. So graph C shows acceleration. Graph D, likewise, shows a constant speed, which is another way of saying no acceleration. So graph D shows a constant speed. I hope this discussion was a lot of help for you. Please ask me any questions you have in class. If you like this video, please click like and subscribe, and I'll see you in class.